You're watching the first video in rates, ratios, and proportional reasoning. The first section of this unit will be talking about ratios. This unit's pretty long, so I recommend watching these videos a little bit at a time so that you can have time to practice and sort of digest the information that's coming in. So I'd like to start with the question of what is a ratio? What makes a ratio a ratio? Well, a ratio ratios are used to show and compare different amounts or different proportions or different things, right? So I'm just going to fix that right now so you can see me edit. There you go. Ratios are used to show and compare amounts, right? So for example, you have 2 to 1. What this ratio means is whatever the 2 represents, it's 2 times more than whatever the 1 represents. So let's say I had a set of apples, and I had 8 apples and 4 oranges. Well, we know we have 2 times as many apples as oranges. So you could say the ratio is 2 to 1, because we have 2 times as many apples as we do oranges. So these are ratios comparing 2 amounts. 2-term ratios are comparing 2 amounts or proportions. So what is the ratio of red to blue balls? I find ratios are easier to show through examples, so I'm going to do a lot of examples. So what is the ratio of red to blue balls? Well, we look at this box, hopefully, there you go, and we compare the 2 types of balls that we have. So we have red balls, 1, 2, 3, 4. So we have 4 red balls, and we have 1, 2, 3, 4, 5, 6 blue balls, right? And so we'd write this ratio as 4 to 6, right? The number of red with a colon and the number of blue. That's the ratio of red to blue. That's it. That's all ratios are. You're comparing 2 values to each other, and you denote this by using a colon right in the middle there. So from red to blue, and this is the total. So there are 2 types of 2-part ratios. There's part-to-whole ratios and part-to-part ratios. Part-to-whole ratios are comparing something to a whole set, right? So you're comparing a part of something to the whole thing. So if I were to do a quick example off the top of my head, I have 10 marbles in total, and 3 of them are blue. 10 marbles in total, 3 of them are blue. So the ratio I would write in comparison would be 3 to 10, right? The part is the 3, it's 3 blue ones, and 10 is the total. While part to part is a ratio comparing one part of a set to another part of a set. So let's use our marble example again, and we say, okay, I have 10 marbles again, but 4 of them are blue, and 3 of them are red. 3 of them are red, right? We know we have 10 marbles. I said we had 10, but we're comparing the blue to the red, so we don't have the total. And that's really the difference there. Part to whole, one part of the ratio is the total. Part to part, you're comparing 2 separate parts. So let's start with part to whole. This is a ratio comparing a part of something to the whole set. In our example, we have what is the ratio of blue to the total number of marbles? Well, we have 6 blue and we have 10 marbles in total. 1, 2, 3, 4, 7, 8, 9, 10. Right? 10 in total and 6 blue. So the ratio will be 6 blue, the part to whole, so the part and the whole set, 6 to 10, right? And that's all a part to whole ratio is. So part to whole ratios are just like fractions. When you're talking about part to whole ratios, you can represent them as fractions. You can represent them as fractions. So here we have 6 to 10. You could write this part to whole ratio as 6 over 10. And they would be basically the same thing. One thing I'm going to say though, don't just automatically convert part to whole ratios to fractions, because sometimes you may make the mistake of turning a part to part ratio into a fraction. So unless the question says turn this into a fraction, don't turn it into a fraction. If it says ratios, give your answer in ratios. If it says fractions, put your answer in fractions. Just read the question and understand what it's asking for. So part to whole ratios can be represented as fractions, right? And the reason for this is because fractions are the part to the total number of parts, right? So if I have 3/4 of anything, I'm saying I have 3 out of the total of 4. And here we're saying 6 out of the total of 10. So part to whole ratios are the same as fractions. And if they're the same as fractions, you can simplify. You can simplify part to whole ratios. 6 to 10 is the same as 6 over 10, and you can simplify 6 over 10 to 3 over 5. So that means you can do the exact same thing here. This ratio is telling you the total and the number of objects that make up the part the question's asking for, right? The question's asking for blue marbles. So 6 blue marbles out of a total of 10. Now this is saying is a fraction 3/5, right? 3/5 of the total number of marbles are blue. And so part to whole ratios can be represented as fractions, and they can be simplified. And so what that means is you must always simplify your ratios. Always simplify your ratios. If you don't, I don't want to take marks off for that. So simplified ratios. The simplified ratio now shows the relationship between the blue set and the total set, right? So this is the actual hard number, right? There are 6 in total of a set of 10 blue marbles. So we have blue marbles, 6 blue marbles in a total of 10. And this simplified ratio is telling us the proportion, right? The relationship between the blue and the total number of marbles. Simplifying ratios, so simplifying ratios is the same as simplifying fractions. And what that also means is because part to whole ratios are just like fractions, you can turn part to whole ratios into fractions. You can also turn them into decimals, and you can also turn them into percents. So you should know by now how to convert fractions to decimals to percents. We're just adding one more thing, and again, part to whole ratios that represent the total number of objects that you're looking at, can be converted into fractions and then can be converted into decimals and percent. So we'll do a little bit of practice here. If you want to pause the video and work on this on your own, feel free to. I'll just do a quick second pause and then we'll solve 2 of these together. All right, so we're going to do this one. We're looking for the part to whole ratio, right? We're looking for the part to whole ratio as a fraction, a decimal, and a percent. So when we look at this box, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the whole set is 10. So we can write this as 10. And we're looking for the part to whole. So the part we're looking for is green. So I'll use green. We have 1, 2, 3 greens. So we have, sorry, why did I write 6? My apologies. We have 3 greens, right? So we have 3 green to the total of 10 marbles. And so this would be our ratio. And again, since it's a part to whole, this part to a whole set, we can convert it into a fraction, which is 3 over 10, which can then be converted into a decimal. You should know how to do this. 3 over 10 is 0.3. Common mistake I see kids make, they do 3-3, it's just 0.3, which then you can convert into a decimal, and again, you can convert it into 30%. Right? So part to whole ratios can be converted into fractions, decimals, and percents. Let's do the next one. The the ratio of yellow to the total. So how many do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our whole set is 15, right? And so we go boop, boop, get that ratio dot, and then we count up our total number of yellows. 1, 2, 3, 4, 5, right? Hopefully it's easy to see. We have 5 to 15. That's our part to whole ratio. Are we done? No, because we can simplify this ratio, right? As a fraction, we can simplify this. As a ratio, we can simplify this. What can we divide 5 by that we can divide 15 by? Well, 5 can be divided by 5. That would make it 1. And we can do this, and we can turn this by dividing it by 5, which would give us 3. And so now we have a ratio of 1 to 3. We can also do this as a fraction because it's a part to whole ratio. So it'd be 1/3. And then as a decimal, it'd be 0.33, right? And we can turn that into 30%, right? We can turn that into 30%. So that's how you convert part to whole ratios into fractions, decimals, and percent. So on your own, try and solve these two so that you can practice on your own, and you just follow the same steps. You look at what part is it asking for, in this one, purple. All right, so I count up the purples, and that's the first part of the ratio. That's the part. And then you look at the whole, which is the other section of the ratio, and you count up all the marbles there, and then you get the other part of your ratio, and that's it. That's all you got to do. And then the ratio, if it's part to whole, can be converted into a fraction by just taking the first number as your numerator, your second number as your denominator, and it's the same stuff we've done since the beginning of the year. So, part-to-part ratios. These are ratios that compare parts of a set to another set. To another part instead of the total, right? So we have two parts that we're looking at. We're looking at two parts. And so we have this set of marbles, and we're looking for the ratio of purple to red. We're looking for the ratio of purple to red. So we have purple. Yeah, 1, 2, 3. We have 3 purple, right? And we have how many reds? 1, 2, 3, 4 reds, right? 4 reds. So purple to red, and we have a ratio of 3/4, right? 3 is the number of purple, and the 4 is the number of red. So when we look at this, we can see that we're not using the total. We are not comparing the total. We're only looking at one part and the other part, because this is a part-to-part ratio. This is a part-to-part ratio, right? In the other set, we looked at the total, so we count up the total. In this one, we don't. We look at the part that it's asking us and the other part it's asking us. Can part-to-part ratios also be shown as a fraction? Well, part-to-part ratios cannot be shown as a fraction, right? And the reason for this is because if you were to convert our previous one into a fraction, it's saying something else. Here we're saying that the purple marbles take up 3/4 of the red marbles. It doesn't really make sense because the denominator represents the total number, not a separate part. So you cannot represent a part-to-part ratio as a fraction. And so this is where a lot of mistakes can happen, because students will see a ratio and then they'll convert it into a fraction, but they don't realize that they've made a part-to-part ratio. So don't make that mistake. You want part-to-whole ratios. those can be turned into fractions. And part-to-part ratios don't get turned into fractions. And so again, the safe rule is only turn a ratio into a fraction if the question asks for it. If the question says, "Hey, turn this into a fraction," then you're probably dealing with a part-to-whole ratio already. And so a little bit of that work is done for you, and you know that you can do that. But if it doesn't say turn the ratio into a fraction, odds are you're dealing with a part-to-part ratio, or you're dealing with a part-to-whole ratio that doesn't want a fraction anyways. So don't turn your ratios into fractions unless it asks you to, and then you'll be safe. So can a part-to-part ratio be simplified? And yes, it absolutely can. So in this example, we have a series of rectangles, each different colors. And you're looking for the ratio of green to purple. So we have 1, 2, 3, 4 green, right? 1, 2, 3, 4 green, and 8 purples, right? 8 purples. And so this is the ratio of the hard numbers. There are absolutely 4 green ones. And there are absolutely 8 purples. But we can simplify this ratio into 1 over 2. And what this is saying is that if we look at the relationship between green and purple, for every one green, we have 2 purples. For every one green, we have 2 purples. 1 green, 2 purple. 1 green, 2 purple. 1 green, 2 purple. 1 green, and 2 purple. Right? So this is telling us the relationship. This is giving us the hard numbers. And so simplifying a ratio gives you the relationship between the two values or two objects that you are looking at. So now we have the relationship. It's a 1 to 2 ratio. Every one green has 2 purples. And this one gives us the whole numbers. We have 4 green and 8 purple. So what is the ratio from green to blue? Right? We can do this one. Pause the video if you want to do it on your own. So what is the ratio of green to blue? Well, we have 1, 2, 3, 4 greens, and we have a 1, 2, 3, 4 blue, right? We have a 1 to 1 ratio, right? We can simplify this as 1 to 1 because we can divide 4 by 4 and 4 by 4 again. So 4 divided by 4 is 1, and 4 divided by 4 is 1. So we have a 1 to 1 ratio. And what that's telling us is for every green, we have 1 blue. 1 green, 1 blue. 1 green, 1 blue. 1 green, 1 blue. 1 green, 1 blue. And so again, the unsimplified ratio tells us the total numbers, right? 4 greens, 4 blues. And the simplified ratio shows us the relationship. For every 1 green, there is 1 blue. Right? And then you could ask other questions, be like, oh, what if I had 8 greens? Well, if this ratio was applied to what the question was asking, and it said, what if you had 8 greens? And because you know for every 1 green you have 1 blue, you should know that you also have 8 blues, if this ratio applies to that question. So, what is the ratio of green to red? Again, you can pause the video and you can solve this one on your own. We're just going to do this together. So the ratio from green to red. So again, green to red, not the total. So we're dealing with a part-to-part ratio. So I'm going to look at my green ones. There are all my green ones right here. We have 4 green ones. And we have, let's pick a different color. Let's pick red. 3 reds, right? We have 4 greens, 3 reds. And so the ratio would be 4 greens, let's pick green, 4 greens, right? And then colon, and 3 reds, right? 3 reds. So we have 4 greens and we have 3 reds. And so this would be our ratio. And because it's part to part, the question's not asking you what is the ratio of green to the total number or green to the whole set. We're looking for green to red. We're looking for the green part compared to the red part to part. So it's a part-to-part ratio, and I don't need to show this as a fraction because I can't, right? What is the ratio of yellow to orange? So I'm just going to use red, and we have yellow. We have two yellows here, and orange. I'll use actual orange, right? Right? So now we have the ratio of yellow to orange. So yellow is 3, right? And orange is, sorry, my bad. I fixed that right away. Sorry, yellow is 2. Yellow is 2. And then we go colon. And then let's get the orange pen. And we have 3 oranges. So we have a 2 to 3 ratio. And again, what this is saying is for every 2 yellows, you have 3 oranges. Right? For every 2 yellows, you have 3 oranges. So let's do another practice question, because it can be challenging to sort of understand that ratios are a relationship between two objects or two things. And so the more practice you have, the more it makes sense as you do it. So we're looking at this grid here, and we have some rectangles that are colored, some rectangles that aren't, and some are different colors. So we're looking at this ratio of 3 to 1. So what in this picture represents a 3 to 1 ratio? All right? So pause the video if you want to solve it yourself. We're just going to solve it right away. So a 3 to 1 ratio. So I like to do this. I like to look at, okay, well, how many of each kind of square do we have, or rectangle? We have 1, 2, 3, 4, 5 black, right? We have 5 black. We have 1, 2, 3, 4 oranges, right? And we have, and I can't obviously use white, so I'll use blue, 12 white, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 white. So what is this ratio showing us? What does this ratio represent? Well, does the 3 represent the 5 and the 1 represent the orange? Well, if this was a 5 to 4 ratio, could I simplify that to 3 to 1? No, right? What if it was orange to 12, or orange to white, right? Okay, well, we have a ratio of 4, right? 4 orange to 12 white. Well, that seems kind of right? If you simplified this ratio, 4 to 12, we would end up with 1 and 3, because you can divide 4 by 4 to get 1. You can divide 12 by 4 to get 3. So if I have this, then I can just swap the numbers, right? So I'll just flip the numbers around, and I'll end up with 3 to 1. Oh, so it's the same ratio. But in our ratio, the 3 represented the white, and the 1 represented the orange. So because we flipped them around, we know that this one is the white, and we know this one is the orange. So the ratio 3 to 1 represents the relationship between the white squares to the orange squares, right? Our first ratio here that we kind of got the answer on was orange to white, but it was actually white to orange. So what kind of ratio is this? Is this a part to whole ratio or a part to part ratio? Well, because we're comparing orange to white, white to orange, sorry, not orange to white. Because we're doing that comparison of two different parts and not the total, then we have a ratio that is a part to part ratio, right? It's a part to part ratio. So, three-part ratios. Three-part ratios are basically the same as a part to part ratio. They're effectively the same, it's just you're comparing 3 parts instead of 2. So when we looked at this one, we had 2 parts. So we showed 2 parts in our ratio. In a 3-part ratio, we have 3 parts. So we show 3 parts. So in this example, we have the ratio of red, orange, and green. So again, if I circle the red, and then I can circle the orange. Don't like switching colors. Circle the orange. Right? And then I'll pick green for green. and we're comparing those three parts. I shouldn't say set, those three parts of this set. So we have the set of triangles. This is the total. And we're comparing red, orange, and green. So how many reds are there? 3. So the first number will be 3. Orange, how many oranges are there? 3. So that's going to be 3. And green is 4, so we put 4 there. So a 3-part ratio is not really that much different than a 2-part ratio. It's just you're adding an extra part. That's it. You just have a 3 to 3, orange and red, and then also green, 4. So you just have another colon here and you add the 4. Can you simplify 3-part ratios? Can you simplify 3-part ratios? Yeah, right? So what is the ratio of the 3 colors of the marble? Sorry, I got cut off there. What is the ratio of the colors of the 3 colors of the marbles, right? So fortunately, I've already put the numbers on, so I don't have to count them up. We have 10 black marbles, 6 purple marbles, and 4 red marbles. Well, you can simplify this to 4, 3, and 2, right? You can simplify this as 5, 3, and 2. My apologies. 5, 3, and 2. How did I do this? Well, if those of you who know how to simplify fractions, you would notice that I divided the 10, the 6, and the 4 by the same number. If you're simplifying fractions, ratios, whatever, you need to simplify by the same number. If I divided 10 by 2 and I divided 6 by 3, then I'm not simplifying properly, right? I need to simplify by the same number each time. So 10 divided by 2 is 5, 6 divided by 2 is 3, and 4 divided by 2 is 2, right? I divided each one by 2 and it worked out. So I got a simpler ratio. And again, this first one, the unsimplified one, is telling us the total number of each part, right? The black marbles have 10 in total, the purples have 6 in total, and the 4 is reds totaled. But they represent the total of each part, not the whole set. And so when you simplify them, you're saying, well, the relationship is for every 5 black marbles, I have 3 purple and 2 reds. And for every 2 red marbles, I have 3 purple and 5 black. Right? So a 3-part ratio can be simplified. A common mistake that'll happen is students will do this odd mistake of going, oh, I can divide 10 by 2, so I'll divide 10 by 2 to get 5, good. And then they divide 4 by 2, that's cool. And then they'll divide another number by a different number. And they'll go, oh, 6 divided by 3 is 2. And they would end up with 5, 2, 2. But because they didn't divide by the same number, they didn't simplify correctly. So don't make that mistake. So we're going to make a 3-part ratio of red to blue to green. Okay, well, how many reds do we have? 1, 2, 3, 4. So we have 4 reds, right? Colon, blue, 1, 2, 3. 3 blue and green, 1, 2, 3. So we have a 4, 3, 3 ratio, 4 to 3 to 3 ratio. Can I simplify this? Can I divide 4 by something? That I can divide 3, that I can divide 3. Well, 3 is only divisible by itself, 3 and 1. And 4 cannot be divided by 3. So it can't be simplified, so we stop there. Let's take a look at yellow, green to blue. So we have 1, 2, 3, 4 yellows, right? 4 yellows, 2 greens, right? And how many blues? 1, 2, 3. 3 blues. Again, can I simplify? Can I divide 4 by something that I can divide 2 by, that I can divide 3 by? Well, I can divide 4 by 2. I can divide 2 by 2. But can I divide 3 by 2? No, not unless I wanted not unless I wanted to keep a whole number, right? If I didn't want to keep a whole number, I could divide it by 2 to get 1.5, but I want to keep my whole numbers, right? So 4 by 2 by 3, I can't simplify this because 3 cannot divide by a number that 2 and 4 can. So a common mistake people would make, they'd be like, oh, I can divide this by 2, I can divide this by 2, and then they would just keep the 3. And that's not correct, right? That's not correct because you divided this by 2, you need to divide by the same number. And that's a very common mistake, so don't do that. So what is the ratio of red to black? Okay, we have red, 1, 2, 3, 4, 5, 6. We have 6 reds, and the ratio is red to black, so we go 1, 2, 3, boop, boop, and we go 3, right? So we have the ratio of 6 to 3. Can I simplify this? Yes. So I can take the 6, I can take the 3, I can divide both by 3. So I divide 6 by 3, which gives me 2, and I can divide 3 by 3, which gives me 1. So I have a 2 to 1 ratio. What this is saying is, for every 2 reds, I have 1 black. And we can prove this by just looking at it. 1 red, 2 black, right? Sorry. 1 black, 2 red, right? 1 black, 2 red, 1 black, 2 red, and so on. So you can prove this by just looking at it, right? This black has 2 reds, this black, 2 reds, this black, 2 reds. So this simplified ratio shows us the relationship, and this unsimplified ratio just shows us the actual numbers. So what is the ratio of blue, red, and black? Well, blue is 1, 2, 3, so we have 3 blue. We have 3 blue. We have red, which we know is 6, and black, which we know is also 3. And I can simplify this because, again, 3, 6, and 3 can all be divided by 3. They can all be divided by the same number. 3 divided by 3 is 1. 6 divided by 3 is 2. And 3 divided by 3 is 1. So we have a 1 to 1, 1 to 1 ratio. 1 to 2 to 1 ratio, sorry. So here we have 1 to 1. So that means for every one blue, I have 2 blacks and 2 reds and 1 black, right? So there's a blue. We have 2 reds here and 1 black. There's another blue. So we have 2 reds and 1 black. There's another blue. 2 reds and 1 black. And so the ratio is showing us the relationship. So good practice questions for you to do, page 51 to 54. Again, this is a big unit. It can get kind of complicated, so I recommend practicing. All right, so I'll see you next lesson.